All right, problem number 43 right here asks us to write the integral as a sum of integrals without absolute values and evaluate. Now, we've gone over this a couple times, guys. Evaluating the integral of an absolute value function is tricky because absolute value is an unnatural function. It's man-made, and it kind of follows its own rules. It's not really a naturally occurring function. So let's graph this out real quick. Okay, that's what we've got there for the absolute value of x, and we're dealing with a region right here that is starting at -2 and ending at +1. So we're looking at this region right here. And then right there, guys, we're looking at that region as well. Now, back in section 5.2, we would have just used the area here in order to evaluate this function here. And take a look at where we're at with this one right here, guys. Yeah, sorry about that. All right, so what we're looking at right here then is for that area, this chunk right over here, we've got a base of 2, and that would be a height of 2 as well. So 1/2 times 2 times 2, area is equal to 2. And over here, it's 1 times 1 and half of that. So half of 1 times 1, your area is equal to 1/2 there. So I believe we would add these two together, and the overall answer we're looking for here should be 2.5. Now, what did they want us to do here, though, guys? They wanted us to rewrite this as another integral here that did not use absolute value. To do that, you've got to break this function right here at the origin, guys, and realize that prior to that point, this is the function y equals -x. And after that point, it's the function y equals +x. So we could make this an integral from -2 to 0 of this function right here, of -x taken with respect to x, and then add to that a second integral now on the right side that starts at 0 and ends right here at 1. But now the function we're following is y equals x dx. So let's see if this works for us here, guys. This first integrand, we're going to get a -x to the second power, and dividing by 2, that's a -1/2 x squared, evaluated from -2 to 0. Plus, this antiderivative now is going to be a 1/2 x squared, evaluated from 0 to 1. So let's see where this gets us, guys. Probably not a big deal. I'm going to leave the 1/2 in there. So -1/2 times 0 squared, that's going to get you a 0 here. And then minus, this gets a little tricky here, -2 squared is +4, but +4 times a -1/2 is going to be a -2. So it's 0 minus -2. And that is what we get from the first integral. Plus, let's move on to the second one now. Let's put a 1 in for x there. 1 squared is 1, times a half is 1/2, minus 1/2 times 0 squared is going to be 0. And I think you guys can see this now. The minus negative turns both of that into a plus. That's 2. And here's a 1/2. And so we end up with the answer we expected all along of 2.5 or 2.5. But the way we did it here on the bottom, that was satisfying the instructions that they gave us here, where we write the integral as the sum of integrals without absolute values. So the first way up top, we did it with area. That was definitely the easier way to do it. But the second way we did it was to rewrite it as the sum of two different integrals, realizing that we have two different functions that we're following, one on the left and one on the right. So that's number 43.